And then after the granite cooled, these radiohalos formed. So it could have nothing to do with God creating these halos or the polonium or the granites. So this means that we had to develop a new model for understanding how these polonium radiohalos could form. Well, the clue is this. Think about it. Here we have a uranium-238 halo down the bottom there. On the bottom right, we have a polonium-210 halo. It's in the same biotite flake. What is inside the uranium halo? What is at the centre? A zircon crystal. What's in the zircon crystal? Uranium. What is the byproduct of uranium decay? Polonium. The closest source of polonium to the polonium radiohalo is the polonium being produced by the zircon crystal at the centre of the... That's why the two are in the same biotite flake. And so this was a clue. Maybe the polonium has actually been derived from within the biotite flake from the zircon crystals containing the uranium nearby that is also at the same time producing the uranium radiohalo. Where did the polonium came from? It had to have come from the zircons, which are also generating the uranium radiohalos. So it's quite logical. The uranium is going to decay down to polonium before it gets to lead. What if some of that polonium was siphoned off or transported away from the zircon crystal to another location in the same biotite flake where it concentrated and then produced the polonium radiohalo? That makes a lot of sense. That's why they're in the same biotite flakes. But see, that's going to have lots of implications. This means, because it's in the same biotite flakes, the uranium and polonium radiohalos had to have formed at the same time. Now, one thing that we know about granites, when they cool, the hot granite rock has water in it. When it cools, the water comes out of solution in the molten rock, and it's part of the mechanism for carrying heat out of the granite into the surrounding rocks. A lot of the ore deposits, the metal deposits that we find on the earth today that are associated with granites, are a result of the water flushing the metals out of the granite and causing the metals to concentrate in veins as gold, in gold deposits, or veins and tin deposits in Cornwall in England, gold deposits in veins out of granites associated with water. So water is produced by granites. Now, the biotite flakes are actually like the pages of a book. They're sheets of atoms that are stacked on top of one another. And just as you can peel apart the pages of a book, you can peel apart a biotite flake. This is a natural weakness. So as soon as you get water in the granite, after the crystals have all formed, water not only flows between the crystals, but it has a passage where it can flow between the sheets in the biotite crystal structure. And that's what I've illustrated on the side here. Looking at the side of the sheets, those lines across the page. Now, the zircon crystal is stuck between two of these sheets. Water flowing along there is going to pick up any polonium. Hot water actually is good at dissolving polonium. We actually find polonium in some volcanic waters. Interesting, polonium was also in the volcanic gases when Mount St Helens erupted, polonium-210, the longest lived of the polonium isotopes. And we find polonium in hot water springs on the ocean floor. So it can travel distances in hot water. We've actually measured that in the real world. The phosphate rock in Florida has background uranium in it, and polonium is in the groundwaters, and it travels for some miles in the groundwaters. So it's known to travel in water. So the water flows between the sheets. Uranium in the zircon crystal, you can see that there, is decaying to produce polonium. And notice the polonium radiohalo is on the same sheet, between the same sheets. Why? Because when we ripped it apart to look at it under the microscope, there was the uranium radiohalos, there was the polonium. They're on the same page of the book. Okay, so that's another clue. The uranium, but remember, the uranium decay has to deliver enough polonium to generate 500 million to 1 billion alpha particles to form each dark polonium radiohalo before the polonium decays. So you've got to transfer that much polonium from the zircon crystal across to form a polonium radiohalo nearby. That is at least 100 million years worth at today's rates of uranium decay has to have occurred within days to produce all the polonium before it decays to form the polonium radiohalo before the polonium was all gone. You follow what I'm saying? These two radiohalos have to form side by side at the same time. If the polonium comes from the zircon crystal by uranium decay, but the polonium radiohalo forms within days or hours, depending on which polonium atom it is, the uranium has to decay to produce that polonium. The uranium has to, while it's decaying, is producing the uranium halos, while it's producing the polonium to produce the polonium radiohalo. So that means 100 million years worth of uranium decay has to form in just a few hours, minutes or days while the uranium forms. See what I mean? This is evidence for accelerated nuclear decay of uranium. 100 million years worth of uranium decay in just a matter of days to form the polonium radiohalos right alongside. And we find this consistently in granites all around the world. And so that's why we concluded in the rate research that dark uranium radiohalos in many granites around the world are observable physical evidence that abundant nuclear decay has occurred at least 100 million years worth at today's decay rate. Coexisting uranium and polonium radiohalos in many granites around the